Hello everyone. Today's lectures we have see the topics phenol. In these topics, the last times we have see the hydrogen bonding, two types of hydrogen bonding, intra and intermolecular hydrogen bonding. And these hydrogen bonding which affect the acidic properties of the phenols. In these reactions, C are here. These orthonitrophenol and paranitrophenol. The paranitrophenol has high boiling points than orthonitrophenol. Why it is observed? Because the orthonitrophenol, which is present one type of hydrogen bonding, which is intramolecular hydrogen bonding. Last times we have seen what is mean by intramolecular hydrogen bonding and what is the intermolecular hydrogen bonding. So this orthonitrophenol has the lower boiling point than paranitrophenol due to it is a higher vapor pressure at 100 degrees centigrade, but orthonitrophenol is steam volatile and which is can be separated by steam distillation method. Next property, acidity of phenols. Phenols are weak acidic than carboxylic acid but stronger than alcohol. These parts which are very important. Now we have see the resonating structures of the phenols. These phenols are this lone pair of the oxygens which act as the electron donating resonance effect. So this is the resonating structures of the phenols, and it is a phenoxide ions. This is a phenols and this is a phenoxide ions. It is the resonating structures. So it is a lone pair is given to form negative charge is here. Firstly, isomerize these structures. Second, negative charge is here. Then this negative charge is localized to form negative charge is here. This charge next is here, and then this is a resonating structure. That is a resonance hybrid. From these structures of these phenols and phenoxide ion, we are shows that the resonance structures of the structure third, fourth, and fifth. See here, the structure third, fourth, structure fifth. The separation of positive and negative charge which require more energy, but in phenoxide ion there is no separation of charges. Instead, there is delocalization of negative charge is take place. Now see is here the second structure third, structure fourth, and structure fifth. This is separation of this negative and positive charge. It is also separation of negative and positive charge. Here also separation. We compare this structure third and this structure third, structure four and structure fifth. This separation of charge which is not present in phenoxide ions, but separation of the charge in this phenol can take the more amount of energy as compared to phenoxide ion, and these phenoxide ion which are more stable. But there is delocalization of negative charge and hence resonance hybrid of the phenoxide ions which are more stable than the phenol, and they can easily eliminate a proton and forming the more stable phenoxide ions, and therefore phenols are weak acidic in nature because the separation of the charge is take the more amount of energy. Then next explanation, phenol is more acidic than alcohol. The first explanation we have seen is here. The phenols are weak acidic than carboxylic acid. Phenols, we have seen the resonating structures, but whereas alcohol does not show the resonance structures. Phenols are show the resonance structure, which is resonance plus R effect after removing the protons to get this phenoxide ion, and these phenoxide ions or another is alkoxide ions, phenoxide ion which is stabilized by the resonating resonance effect. But this alcohol, after removing the protons to get alkoxide, and this alkoxide which is not stabilized by resonance, and therefore alcohols are weakly acidic than the phenol. Phenols are more acidic than alcohol. Why? It is after removing the proton to form phenoxide ion, this phenoxide ion which is stabilized by resonance. The next point, effect of electron withdrawing substituents. Electron withdrawing groups or electron withdrawing substituents like the nitro group, halogens, increase the acidic strength of the phenol due to inductive effect which is stabilize the phenoxide ion. Hence, electron withdrawing group increase the strength of phenol, and therefore R is electron withdrawing substituent, and after removal of these protons to get phenoxide ions, and these phenoxide ions which are stabilized by electron withdrawing substituents, and therefore electron withdrawing substituents which attract the protons or its resonance effect which is more pronounced for electron withdrawing group due to stabilize this negatively charged phenoxide ion. Next points we have see is here effect of electron withdrawing effect. How will you affect this electron donating group? We are know that like a methyl group, methoxy group, this NH2 group, this group act as a electron donating group. These electron donating substituents on aromatic ring which result the weak of acid due to the negative charge on these phenoxide ions which are inhibit the delocalization or destabilize these resonating structures. Due to these resonating structures which are destabilized phenoxide ions which result the weak acid, and therefore orthocresol which is less acidic than the phenol. We are see is structures like a phenol. These are an electron donating group, and it is electron donating group having a phenoxide ions. These phenoxide ions which are destabilized. Why it is a destabilized? Because these negatively charged oxygens are given the resonating structures are here, and this R group is act as electron donating on this side, so which are destabilized by this phenoxide ion. Now we have see the order of that electron donating substituent and electron withdrawing substituent attached to benzene ring with respect to their acidity, and therefore para-nitrophenols which are more acidic than para-chlorophenol which is more acidic than phenol, which is phenol is more acidic than the paracresol, and which is more acidic than the para-anisole. So this order we are clearly indicate that the electron withdrawing substituent, they will increase the acidity of phenol, and electron donating group, they will decrease the acidity of phenol. One points which are important, which is remaining, like phenols which are weak acidic than carboxylic acid. You know that the phenols are weak acidic than carboxylic acid. You know structure of carboxylic acid, CH3COOH. The removal of the proton in carboxylic acid, these protons which are stabilized along this carbonyl carbon, and therefore the carboxylic acid which is more acidic than phenol. But phenols, after removal of the protons to form this negatively charged phenoxide ion which are stabilized along this R effect. But we compare the phenol, phenols are weak acidic than carboxylic acid. Now we have see the next point, some reactions of nitration, like nitration of phenols. First reaction we are seeing here, by using concentrated nitric acid, the nitration can take place at three positions, like ortho, para, and this ortho means 2,4,6 trinitrophenol will get the product. So by using concentrated nitric acid, then nitration can take place at the three position. Similarly, these phenols are treated with dilute HNO3 at room temperatures to get the two products which are possible, orthonitrophenol and paranitrophenol. So nitration can take place at the ortho positions and the para positions due to electron donating resonance effect of that OH group. So two products are possible, orthonitrophenol and paranitrophenol. Similarly, this resorcinol can treat with concentrated nitric acid and concentrated H2SO4. This nitrating mixture are take to use such a type of products. Why it is observed these products? Because OH molecules, OH is act as a electron donating group are here. This OH group act as a electron donating group are here. But you know that accordingly, the electron donating resonance effect, the which type of the products give the major products. Accordingly, at electron donating group, they gives the ortho and para products, and electron withdrawing group, they gives a meta product which is a major product. We are sees here this OH group act as a electron donating group. This OH group act as a electron donating group, and then the product which are ortho and para directing. We compare these products, then OH group are here. So product nitration can take place at ortho position, like this ortho position and this ortho position, and another is a para position with respect to this OH group. Then we compare this OH group are here. It is also electron withdrawing group. Then we compare this OH group. The nitration can take place at ortho and para position, and therefore nitration can take place this ortho position, and this is a para position. So we compare these two OH group. The nitration can take place at ortho and para position. Thank you.